Okay, in this lecture we're going to start by talking about a transformation of a exponential function. Notice that our exponential function here is f of x is equal to 2 to the x to the minus 1. Now notice that the minus 1 is being applied to the x before the function because it's 2, alright, to the power of x minus 1. So the function process here is raising 2 to this power, which is varying, and we're subtracting 1 off the x before we actually raise it to the power. Right, so we can start starting with the very first basic function, which is just 2 to the x. So when I have 1, I'm going to have 2, and when I have 2, I'm going to have 4. When I have 3, I'm going to have 8, and we have a half here, so we know how to draw this one. So in other words, it's like this. This is our basic function. So this is y equals 2 to the x. Right, now what does this subtracting 1 from the x to begin with actually do? Now notice if we were drawing a, so let's put x here, 2 to the x, and this would be 2 to the x minus 1. Now remember that our domain can be anything, so notice I've drawn x to the negative, let's start with x to the negative 3. So this will be, 2 to the negative 3, so this will be 2 to the negative 3, which of course is 1 on 8, because that's 1 over 2 to the 3. If I have negative 2, this is 2 to the negative 2, which is 1 over 4, of course. Negative 1, this would be 2 to the negative 1, which of course is a half, 1 over 2 to the 1. 0, of course, 2 to the 0 is always 1. When I have 1 as 2 to the 1 is 2, of course. 2 squared is 4. And 2 cubed is going to be 8. Right, now what we're doing here is subtracting 1 off of the negative 3, so that would be negative 4, so this would be actually 1/16. When I subtract 1 off here, that would be negative 3, so this would be 2 to the negative 3, so this would be 1/8. This one here, we'd have negative 1, subtract 1 would be negative 2, so this would be 1/4. Alright, now when it's 0, subtract 1, so that would be 1/2. When I subtract 1 off here, I get 0, so 2 to the 0 is 1. And this would be 2. This will be 4. Now if I went to a 4 here, this would be 2 to the 4, which of course is 16. But if I do this one, it would be 2 to the 3, which would be 8. Alright, so when we go over to 4, we're going to have 8, which is moving it this way. Right there. And then when it's 3, we'd have 4. Like so. When it's 2, we'd get 2. Okay, when we get 1, of course, it's going to be, so let's have a look, it's 4. Let's have a look, so let's make sure we get this right. So this will be 2 to the 3, this will be 2 to the 2, this will be 2 to the 1. Okay, and we have here when it's 1, it's going to be 0 here, so that'll be 1, so 1, 1, right there. Then we go through 0 1/2, which is right there. We go 1/4, which is right there. And then we start just getting smaller and smaller because we have trouble drawing it now. We can see here what actually happened is that we've moved it horizontally, like so. Goes up like that. So this is f of x equals 2 to the x minus 1. Alright, so you can see that we have a stretched it out here. Now we can't, it's very hard to draw it here because it gets so small. The thing to remember is that all the same translations apply. okay? And the ones we're talking about are the ones that we've already dealt with the stretching vertically, shrinking vertically, moving left and right, and of course that's exactly what's happened here. We've moved this curve here to the right 1 based on this x minus 1. Alright, and so you'll see here, alright, that all these same translations apply when you apply these kinds of graphs, and you apply it to the basic exponential graph. Alright, now we next move on to equations. Now, to actually solve equations, we are always going to use the properties that you'll remember that we had. If I have a to the b is equal to a to the c, this is true if and only if b is equal to c. So if I can get the same base here, alright, then the exponents will be equal. Okay. Likewise, if the exponents are equal, then the bases must be equal. Right, so if we look at this one here, alright, the first thing I notice that 9 on 4 could be written as 3 on 2 squared. Okay. Alright, so in other words, if I look at this thing here, I've got a 2 on 3 to the x, and I've got a 3 on 2 to the 2. Now this is upside down. So what I could do is write this as 3 on 2, and this is where you must know your exponential laws. If I change it to a negative x, alright, the negative switches it upside down, and then I have 3 on 2 squared. Alternatively, I could write this one here as 2 on 3 to the negative 2. Either way, it doesn't really matter. But here I have negative x equals 2 or x equals negative 2. Same here, 2 and here, so this will give me x is equal to negative 2, same thing. Right, so our solution then is negative 2. Right, if we look at the next one, we've got a 4 and a 2. We're always looking for ways to write the same base. So we could write this as 2 squared to the x minus 2 is equal to 2 to the 3x plus 3. Now, exponential laws says that this is, and this is this rule here, we'd get this, the product, you see, so I'd end up with 2 by x minus 2, right, to the 2 there, is equal to 2 to the 3x plus 3. Notice the same base, so that tells me 2x minus 2 equals 3x plus 3. I'm going to subtract 2x here, so, and I'm going to subtract 3 here. So I get negative 5 here is equal to x, so it implies that x is equal to negative 5, so our solution is negative 5. Right, this one's a little bit different because we have the base unknown now. So we've got to write this 32. We know 32 is can be written as 2 to the 5. So what I really have here is z to the minus to the half, sorry, and to the power of 5. That's this rule again up here. All right, just in reverse, is equal to 2 to the 5. So what does that mean? Well, that means that z to the half must be the same as 2. Now z to the half, of course, is the square root, so therefore we'd have to square both sides. Okay, so this tells me z is equal to 4, and so our solution is 4. Okay, and this one again, we have a base, alright, that we need to find. Now the thing about 1 on 81 is that we could write this as 3 squared, which is 9, so 3 squared by 3 squared, which is 3 to the 4. Okay, and of course we could write this, okay, as, so let's write this k to the negative 4, then could be written as 1/3 to the negative 4. Okay. All right, and so consequently, because I guess what we could say is this could be to the negative 1 to the power of 4, again using this particular property. And you can see here that therefore, and of course 3 to the negative 1 is 1/3. Okay, and so this tells me that k is equal to 1/3, and so our solution is 1/3. So there's some basic equations to solve and a basic exponential to graph.